No. Come on. Nothing's working. Come on. Why isn't anything working? It's like not sharing to my iPad. It's like really great. Come on. Oh. Like, what is happening? Oh my god. Come on. Don't tell me. Oh my gosh. Here we go. Alrighty, we finally did it. Everyone, let me know that they can hear me. Oh my God, bless. I'm so sorry. I literally started my computer at 4 to turn on for this meeting, and we are just now getting to where we need to be, and I think I just froze again. I'm gonna murder the people that make these Apple products. Okay, there we go. Okay, great. So, you guys turned in or should have turned in homework 2 for full credit last Thursday. Yeah, I did just freeze. So homework 2 was due for full credit. If you need to ever turn in WebAssign homework, it needs to be, you need to like request an extension on WebAssign. It also just helps me keep track of like when it's going to be due, and you can do that through WebAssign instead of emailing me, because sometimes I forget and get your email like 1, 2, and do it there. So homework 3 was posted on Friday, and it's going to be due at Thursday again. Don't forget to do both parts. Some of you have only been doing WebAssign and then not turning in part B. Some of you still haven't turned in part B to homework 1 yet. 2 of your homeworks do get dropped, but I wouldn't rely on it so early in the semester. Okay. So today we're going to wrap up C.2. And remember, C.2 is all about solving quadratics in different ways. So we talked about solving by completing the square. I kind of messed up that one problem. It was a little funky, but we got through it. And then we also talked about by factoring, right? And you have homework on that covers this stuff. That's in homework 3. Okay. So then, if I can easily factor a quadratic, then probably solving via factoring is going to be the best. If I want to, I can solve by completing the square. But sometimes like the fractions might get gross, and like that one problem where it was a little too messy and everything. So we can have a third option. It's called the quadratic formula. Right, it's for when we can't easily factor or complete the square. Bonus, it's also for if when you're asked to do one of these two and you want to check your work, this is a good way to check your work too. So it comes with its own little jingle, right? So if we have the solution to the quadratic equation, so ax squared plus bx plus c equals 0, where a is not 0, because it wouldn't be quadratic, we get that it's going to be, oh man, just drink some tea. All right, so we get x equals, and here's the song, goes negative b plus or minus the square root of b squared minus 4ac da 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 all over 2a. That's the song. That comes with the song because this equation looks ridiculous. Did anyone else ever learn another song for the quadratic formula? I know some people know it to, that was, I think I've written it or something. Other people know it to like Twinkle Twinkle Little Star. Oh my gosh, that's so Gen X to learn it to Rolling in the Deep. That's really funny. Okay. But like this equation looks super random, right? Oh, Yankee Doodle, that's cute. We don't know anything about A, B, or C, but we can just like create this crazy formula. And obviously, since I don't know anything about A, B, and C, I can't really factor from there. So what I can do with ax squared plus bx plus c equal to 0 is I can complete the square, right? Does anyone remember how we complete the square? What's our first step? What am I supposed to do the first step when I'm completing the square? Let's go back up in our notes and look. Where is it? So first we're going to divide the polynomial by the leading coefficient, which is a, and put the constant alone on the one side. All right. So we can subtract c from both sides. So I get ax squared plus bx equals negative c. And then I'm going to divide everything by a. So I get x squared plus b divided by a x equal to negative c over a. Okay, that was our step one from completing the square. What else? What do I do next? We're going to, oh, that's by factoring. Where is, there it is. Add b over 2 squared, right? So b would be this guy onto both sides of the equation, right? So b here, the bigger idea of b is b over a, right? So it would be b over a over 2, that quantity squared, which is the same as, Duke, you're okay, b over 2a squared, which is b squared over 2a squared. Oops, not 2a. 4. All right. So I'm going to add that to both sides. So I have x squared plus b over ax plus b squared over 4ac. No, I got excited. Da, da, da. Minus c over a plus b squared over 4a squared. Okay. Let's help ourselves out and condense these two fractions together. So that would give me what, negative, least common denominator is 4a squared. So I had to do c times 4a over 4a squared plus b squared over 4a squared, which will give me b squared minus 4ac. Do you guys see that? All right, so I have b squared minus 4ac all over 4a squared. And then what is this left-hand side factor to? The whole point of, we're completing the square, so we know it's going to look like x, that's a plus. So this is going to be x plus something. What goes here? Why 4? Let's go back and look at you're completing the square notes, right? So we added b over 2 squared. And so by construction, it should factor into x plus that middle coefficient divided by 2. So we're going to go back down here. So this guy divided by 2, which should just be over 2a. Right, this guy right here. All right, and now we're going to just solve from here. So I take the square root of both sides, and I'll get x plus b over 2a equals, I'm taking a square root, so I can't forget my plus or minus, square root of b squared minus 4ac over square root of 4a squared. So x equals negative b over 2a plus or minus square root of b squared minus 4ac. Oh, let me move this over. Not quite fitting. Square root of 4a squared is just 2a. And I combine that since they have the same denominator, which is oh so convenient. And that's how we get the quadratic formula. You guys didn't really say anything. Is there any part of that that I went too fast through or was confusing? Well, what's confusing about it, Cornelius? Or CJ, sorry. It is a lot of letters,
Yeah,
right?
that's basically it. Like it's just a lot going on. So just trying to figure out like each everything, you know what I mean? Like just trying to stay with it. Like, you know, it's kind of.
So if I like write down the numbers, so this is like part one, step one of completing the square. So is this. That's also part one. Here's part two or step two. Math comes with a lot of letters. They're not going away anytime soon. Here's part two where I added it onto both sides. So this is also step two. This is just some math. I'll call it algebra. And then this is step three. And then step four is to solve. So we're using these letters so that I can quickly call any polynomial into call. And it works with anything. In mathematics, I can't prove every single case with every single number. There's an infinite amount of numbers. So we instead use letters to represent all these numbers. And that's why. So if you just think of A, B, and C, usually if they're letters that are in the beginning of the alphabet, they're eventually going to be numbers. If it's a letter in the later alphabet, X, Y, Z, they're variables and they work differently. Okay? That's just comes with practice and being in math classes. So you see how they fun work. Great. You guys are asking for practice, so let's do some practice. All right. What pen was I using? So I have my quadratic formula right here. So using the following quadratic formula, state all of the solutions. How many solutions am I going to get for a quadratic? Two. At most two. At most two. Right? And we'll talk about how to figure that out with this guy under here in a little bit. So if I can have at most two, I can either have 0, 1, or 2. Alrighty. So when you're first working with your quadratic formula, it's best to write what A is, what B is, and what C is. So can anyone tell me what A, B, and C are? Or if you just want to tell me one of them, that's also fine. So careful, Jared. We write quadratics like this, right here, and we also write them like this. Ax squared plus bx plus c. So x squared and x are always going to be there. A, b, and c are coefficients. So it's the coefficient of x squared, 1. The coefficient of x is 8. And the coefficient of 6 is just its own. It's a constant. So it's 6. So you're just looking for these numbers that are out front. Does that make sense? Yeah. It's a very common mistake. So no hard feelings. All right. So that was kind of the hardest part of doing the quadratic other than just memorizing it. So I have x squared. Let's do negative b plus or minus square root b squared minus 4ac all over 2a. And then you can write under it equal, and then I'm just going to plug and chug, right? So I'm going to have negative 8. It's very common if there's ever a negative involved right here, kind of like this 6. People forget to make it negative, right? So negative 8 plus or minus the square root of 8 squared minus 4, 1 times 6 all over 2 times 1, right? So then I'm just going to simplify this down until I get 2 numbers. So I get negative 8 plus or minus square root. 8 squared is 64 minus 4 times 6 is 24 over 2. So I get negative 8 plus or minus the square root of 40 over 2. Okay, that's not working. I can keep simplifying this too. I think. What can I pull out? 4. So I can pull out a 4 of here. So square root of 4 would give me 2 root 10 over 2. Right, because square root of 40 is square root of 4 times square root of 10, which is just 2 root 10. And then I don't have the answer with me. So we get what? Negative 4 plus square root of 10 and negative 4 minus the square root of 10. How does that sound? Not getting a lot of feedback today, and I know we started late. I hope you're not going to hold that against me. Am I going too fast? Okay. I appreciate the little too fasts. I feel like I have to be fast because we were late starting. So I'll walk through what we did. Right, I found A, B, and C, right? My coefficients, they're always going to be numbers. If I'm putting into the quadratic, they're always numbers. It's never going to have the variable involved at all. So I wrote down my quadratic formula to help me out. And I plugged all my numbers in. And then I simplified. Square knowing your squares really, really helps. I think that's why we had to do them in algebra. And then I really wouldn't like it like this. If I ask you to fully simplify your solutions, I would expect this solution. No, A could be any number. We'll do this problem where A is 4. If you're doing the quadratic a polynomial and you can see a number that you can cancel out to make all your numbers smaller, that's fine. So this was like, so, golly. If I had like 2x squared plus 8x plus 6 equal to 0, I would pull a 2 out of all of that. And then divide by 2 both sides, right? Can you do the last simplification part? And that quadratic is a lot easier to do with those big numbers. Delete. So when we simplified, are you talking about from here? From here. Abby, what simplification part did you have a question on? Oh my, no, I just don't know where you want me to start. Okay. So I'm going to assume that you meant to start from here. -8 plus or minus square root of 40. Square root of 40 is the same as just 4 times the square root of 4 times 10. And then you can pull out that square root of 4, which is just 2. So that's how you simplify radicals. You get it down to, you can't pull any other squared item out. And then 8 is divisible when I divide it by 2, it's -4. -8 divided by 2 is -4. And the 2's cancel out for here. Does that make sense? Yeah. Okay, great. Awesome. And then I just wrote it separately as 2 different ones instead of saying plus or minus. Okay, cool. So now I'll leave that a little bit up. Now I have x squared minus 6x plus 11. So what is A, B, and C for here? Car is right. It's gonna be 1, -6, and 11. That negative is so important because, right, I'm writing negative B, right? So -6 plus or minus the square root of -6 squared minus 4 times 1 times 11 all over 2 times 1, right? And that's going to equal +6 now, plus or minus the square root of 6 squared is 32 minus 44 over 2. So I get 6 plus or minus the square root of -12. Over 2. What do I think? What do you guys think I should do from here? But I still have a negative even if I have that 4. I have a negative in my square root. We can't get rid of that negative. I can't take a negative out of a square root. What happens if I have a negative under a square root? What type of solution do we have? Imaginary, aka not real. So once I see a negative in my square root, no real solution. Absolutely, Abby. Good job. Absolutely. I would just also double check and make sure that, oh, is it 36? It's still negative. All I know is negative. Oh my God, I double booked myself on Friday. Please. -9, still a negative number. If you get a negative number on the radical, quickly just go back and check and make sure that you did all the math under the square root correctly, like I often do when I square things wrong, like 6 squared. Alrighty. So this would be a case of no solutions, 0 solutions, right? I said we could have at most 2 solutions, 0 and 2. -8. You guys keep me on my game. My mental math is bad. Alrighty. So now I've kind of moved my things out of order, right? I know quadratics work with the quadratic formula look like ax squared plus bx plus c equal 0. Well, this guy doesn't look like that, right? You can't apply the same equation without making it look like this, right? Because I need it to equal 0, and probably it would help me to move things into their proper places. So I'm going to subtract 12x from both sides. No, not A. 4x squared minus 12x plus 9 equal to 0. I could have easily just put the 12x like on the other side of the 9. So like 9 minus 12x, but that's not gonna help me. I might get B and C mixed up, right? So just make sure that you're making it look like kind of like a standard quadratic. Usually write with the highest power decreasing down to the constant. So highest power, x squared, then x, then the constant. All right. So what's my A and B and C in this case? Ow.
A is 4, B is -12, and C is 9.
Yeah. Perfect. All right. So I'm going to pop to my quadratic formula. So -12 plus or minus the square root of -12 squared minus 4 times 4 again times 9 all over 2 times 4. Okay, that was my quadratic. I feel like I messed one of these numbers up. That's a 2. Okie dokie. So I have x equals 12 plus or minus, I know 12 squared, it's 144. 4 times 4 is 8. 8 times 9 is 7. 7 plus 2 is 9, 72. And 2 times 4 is 8. I know my 9s tables. Don't know my 8s and my 7s. All right, what is 144 minus 72? Is that also 72? Wait, damn it. 4 times 4. Oh, it's 16 times. Oh, yeah, okay. I thought it was supposed to be 144. Sorry, everyone. That's why you can use calculator on your homework. Okay, so then, it's like I knew it was supposed to be 144. I get 0 right there over 8. That's okay, right? I can take the square root of 0. What's the square root of 0? Oh my God, what? It's 0, right? So I'm just going to have 12 over 8. So 12 plus 0 is 0, which is just 3/4? No, 3/2. And that's it. I have one solution now. Alrighty, that was my only last problem. Does anyone have any questions? We can do this second problem if you guys want to talk to, but I want to talk about some other things. Any questions about current quadratic formula and using it? No comments on my bad mental math. Yay, okay. So let's recap really quickly. Maybe we'll come back to that problem. Recap. So ax squared plus bx plus c equal to 0 will have at most 2 real solutions, right? Yay, that's great, guys. It will have at most 2 real solutions, right? So we saw when, what was it? X squared plus 8x plus 6 equal to 0. That gave me 2 solutions. 4x minus 12x plus 9 equal to 0. Gave me 1 solution. Oops. And when I mean solution, I mean real solution here. And what was my other one? X squared. Oh, I forgot it already. Minus 6. Gave me 0 solutions. Right? How do you guys think, and looking back at the work that we just have done, is how can I just look at a quadratic oh, I write so slow, quadratic, and tell how many solutions it has? Well, that's going to tell all these still have the highest power of 2, but that how many does it actually have? The highest power will tell me at most how many it can have, but how can I figure out what exactly it gave me? But what if I can't FOIL it? I can't factor. Well, foiling it is just expanding after factoring. So if we look at our quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac over 2a. Which part of this equation kind of was the troublesome part of it? I need to look up a word before. Okay. Right inside the radical, right? So we call b squared minus 4ac the discriminant. And that's the word I had to look up because I don't want to spell it wrong. I-N-A-N-T. Discriminant. Okay. Right, that little bit inside of the radical can tell me how many real solutions I have. Right, if we scroll up and look at where I had 1 solution, my discriminant, 0. right? So if b squared minus 4ac is equal to 0, well, then my solution is going to be x equal to negative b plus or minus 0, right? Over 2a, which is just one solution. What am I doing? Is this the button I want? Where's the button I want? There we go. If I have b squared minus 4ac, b squared minus 4ac, because I have 3 cases, is greater than 0. So I have a positive number, strictly greater than 0, right? Equal to 0 is its own case. So if it's greater than 0, that means that I'm going to have a positive number under this radical. And I'm going to have, so I'm going to have like x equal negative b plus or minus something that's positive under here. And that's going to give me 2 real solutions. Really want to emphasize that these are all real. Real. All right, and what do you guys think about if it's a negative number? If my discriminant is negative? I'm gonna highlight discriminant because it's such an important word. No real solutions, right? Because I'll get x, whoopsies. X equal negative b plus or minus the square root of a negative number of a negative, which that automatically tells me 0 real solutions or no real solutions. So I can easily ask you on the exam, how many, without telling me what the solutions is, how many real solutions does this quadratic have? And you would do it with this rationale. All right, does anyone have any questions about the discriminant? Oh. Isn't it crazy? Discriminant is really important. Okay. Thumbs up, thumb down. How are we feeling about the quadratic formula and the discriminant? Oh my God, great. Okay, awesome. So now that we know how to solve linear equations and quadratic equations, we're now going to look at inequalities. And then, oh God, there we go. I need to find my already written notes. How long is this one? Oh, not that long. So maybe we'll finish it today. But yeah, okay. So C.3 is all about solving inequalities, right? So an inequality looks similar to equation, but instead of an equal sign, they're gonna have a less than sign, a less than or equal to. Wait, that's a greater than sign. Greater than sign, greater than equal to, less than, or a less than or equal to sign. Oh no, not on Thursday. I think it depends when we finish 1.4. You guys would have an exam next Thursday. That's currently the plan. I think does the syllabus say this Thursday? Whoops. Yeah, you guys will have more than a week's notice or like a week's notice for exams. We need to finish, God, we're already a week behind. We need to finish 1.4 first, which I hope to do next Thursday to give you guys homework that's due on that exam. And then I think Thursday after next Thursday is a wellness holiday, so I can't even assign you anything that day. But we will talk more about the exam next class. That'll be like our intro. I wish I had more time, but we started like 15 minutes late today. We'll talk about the exam more on Thursday. Okay? I promise you that. You get a practice exam. We'll talk about when our little study session is. It'll be fun. Okay. What was my example? Oh yeah, so remember our example for our linear was like 4x plus 7 equals 19, but now I can say like 4x plus 7 is less than or equal to 19, or I can say like 4x, oh god, 4x plus 7 is greater than 19 and stuff like that. Do you guys remember when we talked about writing intervals and drawing intervals and stuff like that? This is where that comes into play again. I know it's been a while, but I need to prep that stuff, do some other stuff, and then everything builds on itself, right? So we treat solving inequalities similar to solving equations with one additional rule, right? So we know we can add or subtract the same quantity to each side. I can multiply or divide each side by the same positive quantity. But if I want to multiply or divide each side by the same negative quantity, I would have to reverse the direction of the inequality. So the way that I like to remember this is if I have like, I know 2 is less than 5, but if I multiply each side by -1, -2 is not smaller than -5. That's not true. So that's why I needed to reverse the direction of my inequality if I multiply or divide by a negative. Have you guys heard of that before? Right? Just think about that negative passing through the inequality, and it negates the inequality as well. Yeah, this is literally how I remember it every time. Yeah, cool. Okay. So just like when we started talking about equations, we started talking about with linear equations. So let's start by solving linear inequalities. It works the same, we just have that negative involved, right? So I have 4x plus 7 is less than or equal to, that's what that little line under there means, 19. Well, I want to still get, instead of x equal to, I want x some caret of some way and a value on the other side, right? So let's move my constants to one side and get x alone. So how I'm going to do that is I'm going to subtract 7 from both sides. So I have 4x. I subtracted. Do I need to flip my inequality sign? No, I didn't multiply. I just subtracted. That's fine. Less than or equal to, oh my God. I'm so bad at writing these. There we go. And that should be 12, right? And then I'm dividing by +4 until I get x is less than or equal to 3, right? You'll often be asked to sketch this on the number line. Alrighty, so I'm less than or equal to 3. So am I going to be on the left side of 3 or the right side of 3 on my number line? Let's do a different color. Left, right? All the numbers, if I'm less than -3, less than or equal to 3, 1 is going to be one of them. Negative, all negative numbers, right? So I'm going to be all of these numbers. I'm just going to draw this line. And since I'm going to keep going, I draw another arrow, right? What about at 3? We talked about these open brackets and these closed brackets. Is this going to be open or closed? It's a solid dot, absolutely, right? Because I'm including 3. Remember, so this is how I can write it. That's a sketch. And there's another way that I can represent my answer. Do you guys remember? Interval notation, absolutely right, Jaden. Interval notation. And you guys will be asked to write solutions. Yeah, and it's gonna be, I think Ronald forgot a negative infinity. Infinity, why am I writing the word infinity? I have the power to draw. And what about on that 3? Oh, there it is, you did it. Right? So these brackets, this closed dot on that number line, and that equal to, right? All that represents that, yes, 3 is an option. So that's how we can use all these 3 simultaneously, okay? You'll often see sometimes people will write like X is an element of this. I think website might do that. That's just a heads up, this weird E. That means an element of, so X is just in there. But this is how you write interval notation. All right. How are you feeling so far? Great. Awesome. So moving on. Now we have 3x plus 9x plus 4. Let me just double check something. Okay. Okay, yeah. We'll finish this one and then we'll do nonlinear next time. Oh, I don't want to push our exam back. But I might have to a day. Okay. So 3x is less than 9x plus 4. What should I do first? I can subtract 9x. Right, and then I'll get negative 6x is less than 4, right? And I'm going to divide by 6x. I have a review session the evening before your exam, and then Johanna, are you here? Is she here? She's not. She's supposed to come to all of these. Johanna will have her SI those weeks accordingly. She might have a review session before exams, but that's something I would email her. If our exam's on Tuesday, she has her session on Sunday. So there's that. Okay. Now I'm gonna divide by negative 6, right? Divided by negative 6, divided by negative 6. So I get x. I divided by a negative, and I'm going to switch my inequality. So I can also negate my inequality. And that'll give me that x is greater than or equal to negative 2/3, right? We could have also not even had to deal with the negative, right? We just would have had to done a few more steps if I subtracted 3 from both sides. So if I did like 3x, let's say minus 4, it's less than 9. So I subtracted a 4 from both sides and then subtracted 3. X, I would get negative 4 less than 6x divided by 6. And I get that negative 2/3 is less than x. Are those equivalent? Yeah, something is smaller than something, that other thing is bigger than the other thing, right? It's just like saying that. So you could have done it differently and not even had to worry about the negatives. Sometimes that might help. Divided by 2. Yeah. Like divide by 2 and then divide by 3 instead of divide by 6. Yeah. It's the same. Yeah. You're doing it in your division in 2 steps instead of 1. That's fine. If it's fine with you and it's mathematically correct. Great. Just sometimes there are faster ways and slower ways, but if the faster way you have more mistakes, then the slower way might be better. Okay, cool. So now I usually like my equations to look like this. Just reading left to right is a lot easier. But if you get a solution like this is where we're kind of thinking about what numbers are greater than -2/3, right? I know I'm going to put an open dot at 2/3 because I don't know yet. I haven't looked at it. I'm just going to put it there. I don't know if I'm going to fill it in yet. And then I'm like, what's a number that's bigger than -2/3? 0. 0 is my favorite test number. 0. Okay, so I know I'm going to be on the side with 0. All right. So here, let me draw this whole circle. And I am going to have my arrow because I don't have another bound for x. I just know that I can't be smaller than -2/3. Am I going to fill in that circle? No, right? That's an open circle. When you are taking your exam, I really want you guys to accentuate that that is not a closed circle. If you give me this, or not even like oh, it's not open, I'd be like, I can't tell if that's just like how you write it. Just be very clear. All right. And how would I write this in interval notation? Where's my pen? That x is greater than -2/3. Yeah. -2/3, comma, infinity. And neither of those have brackets, right? So only open brackets, so parentheses. Remember, infinity and negative infinity will never have brackets on them. Alrighty. My boyfriend just texted me on his way home. I'm in class. Okay, so let's quickly do this one. Since I was late, would you guys be, I have so many of you. I think I still want to give you guys an exit slip, and it's going to be like, tell me a fun fact about you. Okay. So this is kind of doing something like this when I have two inequalities. It's going to work like, again, I'm going to do the same thing to all sides. Right? So if I add 2, I'm just going to add 2 to all sides. So that's add. So that's going to be a 6 less than or equal to 3x less than or equal to 15, right? So then I'm going to divide all the sides by 3. And then I get 2 less than or equal to x less than or equal to 5, right? And we're good. How can I write this in interval notation? So I'm going to do a sketch. My chat wasn't. So for a sketch, I have 2 is less than or equal to x, which is less than 5. So 2 and 5 are going to be my ends of my variable because x is sandwiched in between them. So I'm just going to draw 2 big circles and I'll fill them in later. There we go. And then this 2, 1. So x is like, you can write this as 2 inequalities if you wanted, like kind of like 2 solutions as we do. So we would say x is greater than or equal to 2 and x is less than 5. So I would include 2. Whee! And just like Abby has told us correctly, that if I wanted to write it in an interval notation, oops, that's not an interval. I'm going to have a closed bracket with 2 and an open bracket with 5. Okay? How are you guys feeling about inequalities and solving linear inequalities so far? Yay. And moving from the sketch to interval notation, is that also going well? Okay, great. All right, so let's do our exit ticket and then we will end for the day. Right, so BLACK943. Please don't forget to do these. These are part of your grade. And then our teacher question of the day is, so tell me a fun fact. It doesn't have to be about you. If you just like have a fun statistics in your head, just tell me a fun fact. Do you also hate technology like I do right now? Maybe. And if you have any questions, I'll be here for a little bit. But I will stop recording in case someone has a question that they do not want to publish.